All right, welcome Math 206 students. This is Dr. McGathy. We're working on section 11.3, which is all about angles. So we're going to go through a couple of vocab words here. First, a pair of angles are called vertical angles. They're created by intersecting lines, and they're a pair of angles whose sides are two pairs of opposite rays. So in this example here, 1 and 3, angles 1 and 3 are vertical angles, and also 2 and 4 are also vertical angles. All right, so you notice that they look like they have the same measure, and indeed they will have the same measure because since three angles here, 3 and 2, are supplementary, meaning they add up to a straight line or 180 degrees, and also 1 and 2 here, these two angles add up to 180 degrees. So if angle 3 plus angle 2 is 180, and also angle 1 plus angle 2 is 180, then 1 and 3 have to be exactly the same. So here's our first big statement, that vertical angles are congruent, meaning they have the same measure. Okay, another vocab word for us are supplementary angles. Two angles are supplementary if they add up to 180 degrees, meaning if you place them next to each other, they create a straight line. So for example, these two angles here, 140 degrees and 40 degrees, they add up to 180. So since 140 plus 40 equals 180 degrees, these angles are supplementary. Normally you'll see them positioned so that they're adjacent to each other, like this one, 130 plus 50 is 180. So if you put them adjacent to each other, they create a straight line. Also, if you have one angle that's say x degrees, its supplement will be 180 minus x. All right, similarly, we can discuss complementary angles, which are angles that add up to 90 degrees. So for example, 60 and 30, a 60-degree angle and a 30-degree angle are complementary, since 60 plus 30 is 90. Usually, if they're adjacent to each other, if they're placed in this type of position, they will create a 90-degree angle because the sum of their two measures is 90 degrees. And for example, if you have one angle that's x degrees, its complement would be 90 minus x. So that's how these are related to each other. All right, and you'll see an example that we did in office hours, or that we'll be doing in office hours, where we discuss vocab words such as transversals, interior angles, exterior angles, alternate interior and alternate exterior angles, as well as corresponding angles. So all of these vocab words happen when you have two lines. They could be parallel or not parallel, that are cut by a transversal. It's a line that intersects the two lines, that intersects in a way other than just line one right on top of the other. Okay, so in this case, the line P would be the transversal. All right, so let's label that. P is a transversal line because it cuts through it intersects the other two lines. So in this example, the angles that are created in between the space made by the two non-transversal lines, those would be called the interior angles because they are inside of the space made by those two lines. So the interior angles here would be 5, 6, 4, and 2. So 4, 2, 5, and 6 are interior angles. Okay, similarly, the angles that are on the outside of that space in between the two lines are called the exterior angles. So it looks like here 1, 3, 7, and 8 are all on the outside of that space. So 1, 3, 7, and 8 are exterior angles. All right, so with those labels, there's a special relationship among the interior and exterior angles that happens when our two lines are parallel. If these two lines are parallel, then it just so happens that the alternate interior and also the alternate exterior angles are going to be congruent. So let's pick out a pair of alternate interior angles. These would be interior angles that appear on opposite sides of the transversal line. So if I say pick the angle 4 here, its alternate interior partner would be the interior angle that's made by the other line. So instead of being made by line M here, it's made by line N. That's on the other side of the transversal. So 4 and 6. And also angle 2 and angle 5. These are called alternate interior angles. Now let's discuss the alternate exterior angles. So this would be a pair of angles that are exterior, so they're not on the interior of the space made by the two lines, and they're on opposite sides of the transversal. So the alternate exterior pair for 1 would be made down on the other side of this figure, on the other side of the transversal. So 1 and 7. 1 and 7. And also, here's another pair of alternate exterior angles, 3 and 8. These are called alternate exterior angles. All right, and then our last vocab word would be corresponding angles. Corresponding angles are, that refers to a pair of angles that are in the same relative position in regards to where the transversal intersects the line. So here, the angles that are made by the transversal and the line N are 1, 3, 5, and 6. And the angles made by the transversal and the line M are 2, 4, 7, and 8. So let's find all pairs, all corresponding angle pairs. Let's just label them all. So angle number 1 here is from the point of view of this intersection point, it's top right. So let's look at the other intersection point and find the top right angle. So that would be angle 1 and 2. So 1 and 2. How about 3? 3 is in the top left position. Move down to the other intersection point. Top left position is angle 4 here. So 3 and 4. Let's look at angle number 6, which is in the bottom right position from this intersection point. By the other intersection point, bottom right, there's angle 8. So 6 and 8 are corresponding angles. And find the bottom left position here. That's angle 5 from the point of view of the other intersection point. Bottom left is angle 7. So 5 and 7. All right. So when your lines M and N and M here, when they are parallel, what it looks like is that the corresponding angles are all congruent. And that is true. It is not true if your lines aren't parallel. So for example, here, let's take a look at the angle 1 and angle 2. It looks like this angle is slightly bigger than that one. They're not the same, but here in this picture, where lines N and M are parallel, 1 and 2 are exactly the same measure. So here's our theorem. If any two distinct coplanar lines, so like N and M, are cut, so here's N and M, are cut by a transversal, that's our line P here, then a pair of corresponding angles, or alternate interior angles, or alternate exterior angles will be congruent if and only if the lines are parallel. Okay, so that says if the lines are parallel, then you can always assume that all the corresponding angles, all the alternate interior, alternate exterior angles will all be congruent. On the other hand, if you find a picture like this and it turns out that one pair of corresponding angles is congruent, then you automatically have that the lines are parallel, and then you get all the other congruences for free.